We have discovered that Snowflake offers the option to write a Snowpark program using Python, Scala, or Java. In the chapter 6, we compared these programming languages with hands-on example. We also explored the secure sandbox capabilities of Python and compared them to Scala and Java. In this tutorial, we will dive deeper into the topic and discuss whether a Snowpark program should be written using Python API or the Scala API. We will take a couple of important considerations into account so you can decide if you can choose Python over Scala or Scala over Python. We will explore the power of Python and Scala programming languages for Snowpark, focusing on several key attributes listed here. The first attribute is flexibility and extensibility. We will examine the features provided by each language to support flexibility and extensibility. This is crucial as teams often need to enhance the data platform regularly to accommodate new changes. Cost efficiency. We will analyze if one programming language is more cost effective than the other in terms of development activities. Ease of maintenance. We will deep dive into the importance of this attribute and its impact on total cost of ownership. Understanding how easy it is to maintain code in each of this language is very crucial. The readability factor. We will discuss how to avoid writing excessive boilerplate code and evaluate the expressiveness of both languages. We will see how this aspect contributes to developers' productivity. Community and innovation. We will explore the kind of innovation and feature development happening within the community for Python as well as for Scala programming language. Support from Snowflake. We will touch upon the level of support and resources available from Snowflake for these programming APIs. By the end of this video, you will have a clear understanding of the strength and capabilities of Python and Scala for Snowflake, helping you to make an informed decision based on your project's requirement. Welcome back to my channel Data Engineering Simplified and to this Everything About Snowpark playlist for true data professionals and data engineers like you. In this episode 12, we will discuss if Python API or Scala API is better for your Snowpark development. We have reached to the last episode of our Snowpark awareness playlist. As you may know, the playlist consists of total 12 chapters. If you would like to explore a specific topic, feel free to pause the video, review the episode list, jump to the episode that interests you most. You can find the link to all the videos in the description section below or in the info card above. These videos are recorded in 4K resolution. Follow the instruction for better resolution and to learn it faster. Before we proceed, I have a quick announcement. I have published more than 100 videos covering different topics under different playlists. And if you find it hard to get into a specific topic or a subtopic or a specific concept, use this summary card for a quick search. Summary card download instruction is given in the description below. For additional queries or a specific question, feel free to drop me a note to my Instagram account. Let's quickly review the Snowpark deployment architecture. You write your Snowpark code using Python API or Scala API or a Java API. When you execute this code and your program reaches to any action method, and in this case, a collect statement on line number 58, the entire data frame is evaluated and gets translated into a SQL statement. And that statement is finally executed into your Snowflake SQL engine. Alternatively, you can also deploy this code inside the Snowpark sandbox. And in that case, your deployment architecture and execution flow will look little different. Your Python byte code will be deployed and will be executed inside the secure sandbox within a virtual warehouse. And it can leverage a lot more libraries provided by Conda. We had seen how to check the available libraries that Snowflake made available using information schema. On the other side, if you write the same code using Scala API and package them as a jar and deploy into Snowflake, it will also run inside a secure sandbox. But Snowflake does not provide any additional libraries for Scala as well as for Java. It has to be bundled as a fat jar or to be provided by uploading them inside the stage location. So the secure sandbox approach looks very different, and that makes your Python code much lighter and easy to manage the dependency as Snowflake provides a lot more libraries. And if you run your Snowpark code as a client code, then everything will be translated into SQL queries, and your client program will interact with Snowflake only for query execution, as we had seen in the previous slide. If you and your team are developing a solution using Snowpark for the first time, it is advisable to use Python since Snowflake provides all the necessary examples, libraries, and support for it. Don't go for Scala, as Scala has a deeper learning curve and we will understand it better in the next slides. Let's talk about flexibility and extensibility attribute. Scala excels in extensibility due to its strong static typing and object-oriented nature. It provides a robust type system that ensures code correctness and facilitates scalability in large-scale projects. Scala's functional programming feature such as higher-order functions and immutable data structure enable developers to write concise and expressive code. It's compatible with Java ecosystem also enhances its extensibility by leveraging existing Java libraries and frameworks. On the other hand, Python is dynamically typed language, which means that variables typed are determined and checked at runtime rather than during compilation. While dynamic type provides flexibility and convenience, it can also introduce certain challenges like type error, readability, maintainability, and performance overhead. Python is multi-paradigm language that supports both object-oriented as well as functional programming style. While Python does not have the same level of functional programming feature as Scala, like immutability, higher order function, pattern matching, and algebraic data type. Python, being an interpreted language, can have performance limitations compared to statically typed and compiled languages like Scala. This has other issues like type safety, concurrency, and parallelism. Python is also not compatible with Java. So, if you compare flexibility and extensibility side by side, Scala certainly wins. But for a small to mid-sized data project, Python is still better. Unless otherwise your project is very large and complex and having Scala expertise in the team, stay with Python as your preferred choice for building Snowpark solutions. Let's talk about cost efficiency attribute. Python is well known for its simplicity and ease of use. It has a large community base, and with its popularity, a lot of development is happening, and it has large and extensible library ecosystem. So finding Python developer is much more easier compared to any other language. On the other hand, Scala is not easy to learn and has a lot of features that are less known, and that's why finding a good resource who has extensive experience with it is a bit challenging. Setting up Scala environment is also complex compared to Python, and that's why building a Snowpark solution using Python API is much more cost efficient compared to Scala. If you compare them side by side on a cost efficiency attribute, Python certainly wins here. For the same reason, it is hard to maintain a Scala system, and you need to have access to good developers and support team members to manage and maintain data platforms built using Scala-based programming language. So, on this attribute also, Python wins. Let's talk about readability factor. Both are expressive language, and if a proper guideline, style check, and best practices are followed, the data team using both the languages can produce good readable code. However, sometimes it is hard to understand Scala code. Here is an example. I would request you to pause the video and try to understand what is written. I personally prefer to choose Python over Scala as it is more easy to understand and easy to maintain. So when it comes to readability attribute, Python is the winner. Both Python and Scala have strong communities and has a history of innovation in the field of data engineering. The Apache Spark framework is built using Scala. However, when it comes to comparing the two in terms of community and innovation, specifically in the data engineering context, Python tends to have a slight advantage. Python has a large and vibrant community of data engineers and data scientists supported by comprehensive libraries and frameworks like Pandas, NumPy, SciencePy, and many more. These libraries provide robust tools for data manipulation, analysis, and machine learning. And again, if we consider community and innovation as an attribute, Python is the winner. The next attribute, how much Snowflake provides support to these two programming languages. When deploying your Snowpark code based on a Python API, you can leverage numerous standard libraries already available within your secure Python sandbox. Snowflake has collaborated with Anaconda to offer growing array of utilities and libraries, ensuring that Python developers face no obstacle in building data platform within Snowflake. You can go to repo.anaconda.com and all the libraries which are available along with your Snowpark secure sandbox is listed here. Alternatively, you can also go to anaconda.org and refer for additional information. It is evident that unless there is a highly specific requirement, building your Snowpark solution using Python API is preferable. It offers advantages such as ease of use, cost efficiency, ease of maintenance, and access to large community for support. If you are interested in comparing the Python API versus Scala API for the same Snowpark logic, you can watch episode 6, which provides a side-by-side code comparison. Episode 6 not only explains the code snippet but also covers IDE setup and demonstrate how to run your Snowpark code as a client. I assume that you found this episode and the entire playlist enjoyable and that it has provided you with a comprehensive understanding of various aspects of Snowflake Snowpark. Thanks for watching this last episode, episode 12 of this playlist. If you have learned something valuable from this episode and from this playlist, don't forget to press on the like button and share with other data engineers and Snowflake developers. Happy learning and keep growing.